Thank you for coming tonight. For the Below the 45th Parallel, the Beginner's Guide to Chasing the Aurora in the Great Lakes Regions, I want to welcome Melissa of Kaelin, the founder of the Michigan Aurora Chasers and the author of Below the 45th Parallel. So thank you for coming.
Thank you for having me. Hi, everyone. Thank you so much for having me. They reached out about doing this program for Oxford Parks and Recreation, and I'm very excited to be here. Driving up is just a beautiful area, so I feel very fortunate to be able to share this with all of you. So welcome. Yeah, you all know me now. This is a program about chasing the aurora borealis below the 45th parallel, which I find to be sort of a magical place. The 45th parallel is the latitude on the map that stretches all the way across the world, and when you're at 45 degrees north, it just seems like cool things start to happen. You start to see really tall pine trees, you start to drive into the boreal forest, you start to see some of our Great Lakes really blossom, and you can also see the aurora borealis, which is why we're all here. So I'm hoping to share some tips with you tonight and answer some questions and maybe help you on your journey chasing the Northern Lights. So how many of you have seen the Northern Lights? Show of hands. I'm going to look around the room and see how many we have still waiting for their first show. Okay, great. All right, how many of you have seen a beautiful photograph of the Northern Lights, even online? Yep, everybody's hand goes up, right? Okay. How many of you have seen the Northern Lights in full color with your own eyes? Anybody? All right, we've got a few. Not everybody's hand went up, though. So that's one thing to kind of note as we go, is that every time you see the Northern Lights, it's going to be a different experience, and you can't always see the color, which is a common misconception. I'm getting ahead of myself here, though. I will tell you a little bit more about me. My first love is writing, so I really come to this from the experience of writing nonfiction. And I've been writing for many years. I also am a bit of a social media guru. And so if any of you, how many of you are members of the Michigan Aurora Chasers Facebook group? Yeah, that's where we do a lot of our live sightings and sharing and education, and it's really a joy to share that with everyone in Michigan and the surrounding areas. And of course, I, as a social media guru, love running it. I also co-founded the annual Aurora Summit. It's been in 2017, so we celebrated our 5th anniversary recently, and that happens every year in the fall. It's a national turned international conference that celebrates the art, culture, science, and photography of the Northern Lights. Because believe it or not, if you really dive in, there's just so many ways to experience the aurora. And I've been doing this for over 10 years, chasing. I've also been an admin of groups for almost 10 years. And I'm coming to you from Ann Arbor, where I am lucky enough now to work for the University of Michigan in the Department of Space and Climate Sciences and Engineering, where I actually get to interview some of the world's leading scientists about the solar wind, the sun and solar activity, and some of that aurora that is coming into Earth's atmosphere and creating our Northern Lights. So that's what I do for my day job. How to catch the Northern Lights. All right, let's get into it. What does it take to see the aurora? Some of you have seen it already, so you might have an idea. Some of you are still waiting for your first show. A lot of people don't realize how much goes into seeing the Northern Lights, especially in the mid-latitudes. We're really, if you were in Alaska or Norway or Finland, those are some of the most northern regions of the world, and those are really what we think of as the high latitudes. The low latitudes are maybe somewhere near the equator or Cuba. So the low latitudes are way below us. And this definition really varies depending on who you talk to, but when we talk about the 45th parallel, a lot of people consider that to be the mid-latitudes, which is where we are in Michigan. No matter where you live in Michigan, it's a mid-latitude for our purposes tonight. And actually, I always like to look it up. This Oxford area is right at 42.8 48 degrees north. So you're almost 43 degrees north, but you're still below the 45th parallel, which is where we see some of our strongest aurora activity. What does it take to see the northern lights? Well, many factors have to align, not only in outer space, but also on Earth. So some of you are probably learning recently that the right conditions on Earth can change. We live really close to the Detroit area here if you're local, and that provides us with a lot of light pollution that can be an obstacle. We really need those clear, starry nights and those dark skies to be able to see the northern lights, especially in the mid-latitudes. If you were in Fairbanks, Alaska, you might be able to see it from the city pretty commonly, even though you're not going to see the greatest show. But as the aurora comes farther south, you need all of those things to kind of work together to give you a beautiful show. So I'm going to go back to my notes here and try to do this in order. You need a really good aurora strength, but also those starry skies. I know I just mentioned that, but this is important because living near the cities and in southern Michigan, we have so much light pollution that sometimes you can look to the north on the northern horizon and you can see a little bit of light, some yellow or maybe a little bit of a greenish color, sometimes some pinks or whites. And you might think it's the aurora, but it's not. It's actually the light of a bulb of city lights, just artificial light shining out on the distance like a beacon. And that happens a lot in populated areas. So we're surrounded by them here. And anytime you have a city to your north, even a city of a smaller size or really a town, you could see that little sort of gathering of lights out on the northern horizon. So keep an eye out for where you are on the map and look for those starry skies. If you're seeing the stars, if you notice in the photo here, if you're seeing the stars through that light, chances are it's not actually light pollution because you are looking into a clear sky. And that's a sign that you could be looking at northern lights. So I often tell people, if you're not sure, look for the stars. Because the northern lights are sort of transparent. They fall across the sky like a veil. You also need dark skies. So we're going to talk about that a little bit more tonight, and I'll give you some tips for finding truly dark skies. The darker your skies are, the more color you're going to see in the northern lights. You can't always see the color, but if you want to increase your chances of seeing the color, find the darkest skies you can, because that's really going to help you out. And then things like the moon phase, if it's a full moon, that light can actually wash out the northern lights and make it very difficult to see, because sometimes the northern lights are really powerful and really colorful, and they can look almost neon in the sky depending on the strength of the storm, how far north you are, how dark your location is. But sometimes they're very subtle. So a lot of people have chased the northern lights and looked out at the sky thinking they're not sure if they saw the northern lights. You may have actually seen it and not realized it. A lot of people mistake the northern lights the first time for like a cloud, a silver or white cloud out in the distance. And that's because sometimes they can be so subtle, it can be hard to tell the difference. Obviously, the farther north you go, and then the camera is always going to pick up more light and color in the dark than the human eye. So keep that in mind. When you see these photos online and, printed out and beautiful banners hanging on the walls, things like that, aurora photography is really colorful and really brilliant. And photographers aren't going in necessarily to edit those photos in Photoshop and bring out a lot of saturation. Sure, they can do that, but even before they touch the photo out of their camera, they're going to get so much color with one photograph and maybe a 30-second exposure that compared to what the naked eye sees. And so that's going to always look more colorful than what you see with your own eye. But during really strong storms, it is possible to witness that for yourself. We also need the right conditions in space. So a lot of all of our aurora activity is created by solar activity. And the solar wind, and we'll talk about that a little bit more too, that has its own composition. We have weather here that we have to try to predict on Earth. You think about a cloudy day or a windy day or rain or snow, things like that. We also have weather that we're predicting in outer space. So technically aurora is created by space weather, and it has its own makeup. It has its own composition, has its own wind speed and density. and things like that pesky BZ. If you're a member of the group, you know that can make or break a night of aurora chasing, and we'll talk about that too. And the best data is always observed in real time. So what causes the northern lights? It's the solar wind. I really like this graphic because it kind of explains in an easy to visualize way what's happening here. We watch aurora data in some of the aurora reports to try to figure out when northern lights are coming with 2 to 3 days in advance, because that's how long it takes for activity on the surface of our sun to, sort of pop out into outer space, maybe release into space, fly toward the Earth, and then enter Earth's atmosphere and create that process that gives us northern lights. So I just kind of take you a minute here because I want to be sure I explain this really well. If you've got an aurora chasing app, you may be looking at some different things, trying to figure out when you can see the aurora or not. A lot of people recommend Space Weather Live. It's a free app. You can download it on any phone, and it has little information bubbles that will kind of tell you what you're looking at. The trouble with Space Weather Live is it's going to give you everything. It's going to give you all the data. It's going to start you out all the way at solar activity and tell you what your chances are of aurora 3 days later. So generally what happens, we have all these different types of solar activity that can lead to aurora if all the conditions align. It could be solar wind eruptions on the surface of the sun. We could get a coronal mass ejection, or a CME. That's created when the sun has a flare on the surface, and those flares sometimes will pop off into outer space, but sometimes with the magnetism of the sun, they'll get sucked right back into the surface. So just because you have a flare or a flare alert on your app, that doesn't necessarily mean it's going to lead to aurora. If that gets sucked back into the sun's surface, nothing happens. But if that flare then creates a CME, and that CME becomes Earth-directed, and that Earth-directed CME makes it past our magnetic field into Earth's atmosphere, then all of a sudden we have a chance of northern lights. So it gets a little complicated. Other things that can cause aurora, these originate on sunspots on the surface of the sun. We've seen some filament eruptions. You can get way into, the science and the heliophysics behind it and learn a lot of different information about all these things. Coronal holes are a big one too, though. We've seen some really good photos of the Michigan Aurora Chasers group recently of the sun through the wildfire smoke, and that's provided enough of a filter for us to actually see these spots on the sun. Some of those are coronal holes that can then blow a really high-speed wind, or solar wind, which is actually solar matter or solar plasma, in Earth's direction, and they can create northern lights when they get here, and that can lead to a really sustained show. So coronal holes can give us some of our most powerful northern lights as well. What happens when all that reaches Earth's atmosphere, though, is it has to kind of travel through our magnetic field, which is these purple lines, and then back through the magnetotail, which is also part of the magnetic field on the back end. And then the solar wind filters through the North Pole and the South Pole, creating the northern lights, or the aurora borealis, and the southern lights, or the aurora australis, which you can really only see in Australia and New Zealand. And that's how we get the aurora. And so in order for that to happen, a lot of things have to sort of align and just be in the right place for that to flow seamlessly into our atmosphere. I knew I was going to lose that. There, it's back. So this talks a little bit more about some of the magnetic field impacts. We also have satellites out in outer space that are helping us to monitor and track this data. So when you hear us talk about the solar wind speed, the density, the BT, the BZ, all these numbers, these are coming from some of our satellites in outer space that are helping to monitor space weather. We monitor the sun, and then we monitor what is happening around the Earth's magnetic field, as well as things like cloud cover, moonlight, some of the things actually in our atmosphere. We use all the data, and then we figure out what's going to actually make an impact on our planet, if that's going to actually go through the process to create northern lights. And sometimes all these factors just don't line up and we get a dud. All that has to happen for this solar wind to not reach Earth's atmosphere is maybe it changed direction. It changes direction about halfway through its journey through space. Some people like to joke that, okay, well, we had a really big solar wind coming at us, or a CME. It must have hit a meteor field, a bunch of just rocks, space rocks, and then maybe got redirected. I mean, that's actually entirely possible. This solar wind has to travel so many millions of miles through outer space to reach Earth that there's actually a really, really tiny probability that it's even going to hit our planet. Because you notice the Earth is a lot smaller than the sun. And it's pretty cool actually. When we talk about the BZ, that is actually, it's a really important factor. In our group, we talk about the BZ as being the gatekeeper. So this is really the determining factor that tells us, okay, northern lights are going to be able to come into Earth's atmosphere, or nope, they're not. What the BZ is, it's a component of the interplanetary magnetic field that is either oriented toward the north or the south. And we're talking about magnets. If you can picture two magnets and how they either attract or repel based on which way the magnets are turned. Or if you think about when you put two batteries in your remote control, you have to have them turned the right way to get that connection and that electrical flow. This is really a geomagnetic electrical current, essentially, that needs that BZ to be aligned with the south and north poles turned in the right direction. And so the BZ is the orientation north or southward of that interplanetary magnetic field. I'm saying that again because I want to point out that the solar wind we just talked about that flies through outer space carries its own magnetic field too. So the Earth has a magnetic field, but so does the solar matter. It's charged in different directions. It carries different properties. There are scientists are studying, and we need that BZ to be southward or negative, which is the same thing. It's either a negative number on your app, or technically it's turned southward in order for it to produce northern lights. Because essentially what's going to happen is that's going to allow the BZ to create a funnel effect. And any of that solar wind flying towards Earth's atmosphere is then going to flow in, without any obstacles. If that BZ turns north or positive, so if you see BZ as a positive number, that's kind of turning off this flow. That's like a disconnection. It's like the magnets repelling one another. And so all of a sudden that gate is closed, the BZ is pushing that solar wind and all those charged particles back out into outer space. And that actually protects our planet from a lot of things. Because believe it or not, the aurora is considered geomagnetic activity, and it can have impacts on our infrastructure. The reason that we get forecasts for these types of events is because they can have impacts on the power grid. We can actually lose power. They can cause satellites to shake in outer space. We have to protect our astronauts against impacts like this because when you're that far out in space, there's a risk for radiation. And so there are actually kind of dangerous implications of the geomagnetic activity that we're trying to protect against. So that BZ, when it turns north, we're like, well, no northern lights tonight. But the good news is it's also sort of protecting the Earth from some of those impacts to our infrastructure. Now, there's one thing that I need to talk about in the Michigan Aurora Chasers a little bit more, which is that there's a trick here. When the BZ is not north and not south, but jumping back and forth, that's actually a sign of instability. And that's a good thing. As Aurora Chasers, we want instability in our atmosphere so that everything is just sort of rocking and wreaking havoc and letting that solar wind in to create northern lights. So if you see the BZ going up and down, positive, negative, and you're not sure where it's at, as long as it doesn't get pinned in one direction, that could actually lead to northern lights as well. I should talk about this graph too before it goes away. So we can actually, any one of you can go to a website and find where the BZ is right now and look at it on a graph. This is a chart that kind of shows you how the numbers are trending. So I like to kind of tell everyone what's on this chart, but I like to start from the bottom up because the top is the most important. At the bottom, you have the temperature of the solar wind. We don't really use that a whole lot in aurora chasing. It doesn't make a huge difference, but anytime you see spikes or a lot of instability in these lines on the graph, that can be a good sign for us as aurora chasers. Solar wind speed is really important. We usually want to see this number above 500 kilometers per second. And so when the solar wind speed is traveling faster, that gives us a better chance of northern lights because that solar wind is really pushing toward the earth and pushing toward our atmosphere. Density is another good one. A lot of people ask, well, how can you determine when you're going to see the color of the northern lights? Well, when we have a high density, that means there are a lot of charged particles, a lot of material and solar plasma in this solar wind, and that leads to an opportunity for more of those to filter into our atmosphere and then create light and color. So the higher the density, the better chance we have of seeing color in the northern lights. Then the phi is one that we don't really use too much, but at the top you see BZ in red, and I know it's kind of hard to see as we're set up here, and BT in white. And the first time I looked at the screenshot that I grabbed, I said, BT isn't there, what's wrong with this? But BT is all the way up at 10 on this chart, which is actually a really good sign. The BT shows the potential of the BZ to go either negative or positive in either direction. So if we have a BT of 10, as we do starting out here, the BZ at any given second, it literally changes instantly, could either go to positive 10 or negative 10. If BZ goes to positive 10 and BT is positive 10, no northern lights. But I get really excited when I see the BT number being really high, because that also means that BZ could at any second drop to negative 10, which is a really low number for BZ and could mean that all of a sudden we get really powerful northern lights. So that BT kind of shows you the potential, and then you can see BZ here, it's sort of jumping back and forth a little bit, positive, negative, positive. As long as it's not pinned to the north or pinned to the positive, there's still a chance to see northern lights. So I like to watch this 6-hour graph. And this kind of maps out BZ on an axis. A lot of people say, well, you know, if the BZ is turned to the south, does that mean they're getting more aurora at the South Pole? No, it's not about north and south at all in a directional sense. It's more about thinking of magnetism or that connection with batteries. And so this shows you that BZ is actually just on an axis, and it's one of the components of the solar wind. All right, so there are a lot of other things to consider if you're going to chase the northern lights. I like to try to help people actually see the northern lights and be successful. And so I try to give you all the tips that are going to help you on your journey. Things to consider. Scout out a good location for chasing the northern lights. Like I said, if you have a city directly to your north, you're probably going to see light pollution and not northern lights. So you really need to get out there and drive around. And I recommend doing this during the daylight and find a really good spot where you have dark skies to your north. You don't have too tall of trees. You know, you have a clear view of the northern horizon. A lot of people like to go to a lake shore because then you can get that cool reflection of the northern lights in a lake. But scout out a location. Go during the daytime, because if you go out there at night and you've never been in this spot before, you have no idea what you're going to find when you get there. You know, we even sometimes scout out our locations on the same day just to make sure that we know what we're getting ourselves into at night. Because imagine, you know, if your favorite field or hill just experienced a ton of flooding and you're really excited to set up your camera, but you go out in the dark and all of a sudden you're just swamped with water. If you scout out your location during the daytime, you can watch for really good opportunities to set up a good composition in your photos. You know, sometimes you might see cool sculptures on the way that you can think about, okay, I'm going to use that in my foreground for my photo later. You might also see signs like no trespassing signs, and then, okay, maybe you want to steer clear of that when you come back at night. And you can also watch out for, just things that you're not aware of. Maybe there's an eagle nest nearby or some sort of wildlife nest even on the ground that you just want to be aware of when you go out at night. So scout out a good location. What you need is clear skies, a view of dark skies, and then just that open view to the north. That's really all you need. You can use light pollution or dark sky maps, and I won't spend too much time on this because we'll come back to it, to find those dark locations near you too. And they're actually easily available online or if you do a Google search. Also, be sure to check your cloud cover and your weather. I've heard a lot of people say that they're seeing the northern lights through the clouds, but that is really, really rare in Michigan. Can you see the northern lights through the clouds? I would say no, because they're not going to shine through a really thick cloud unless it's one of the most powerful geomagnetic storms of the century and everything is just off the charts. However, if you're looking into the clouds and the clouds are sort of patchy and there are holes in them, especially if you're carrying a camera, then sure, you can see northern lights shining through those holes in the clouds, or if you have really thin, wispy clouds, you might be able to see some of it. But in general, you really need clear skies, especially if you're just starting out. What else? Sunset. You actually should probably be out about an hour after sunset, because what happens after sunset is we get twilight, and it has these really pretty colors of green and blue and sometimes purple. And those aren't the northern lights yet. That's just our really beautiful sky in the evening, changing color as it's getting ready for true darkness. And then the moonrise and moonset times can also affect your experience, especially if you're going out near a full moon. A full moon is going to give you a little bit of trouble, especially seeing the northern lights with your own eyes. You might be able to catch it on camera really well under a full moon if it's a strong display, but it's going to be really hard to see. Now, let's say you're going out on a night where it's almost a full moon, but the moon doesn't rise until 2 o'clock in the morning. Well, you've got all that time before 2 a.m. where you could see the northern lights without anything obscuring the view. And then whatever time the moon sets, that's also going to bring back those dark skies. The reliability of the forecast, keep that in mind. We publish these aurora forecasts to help people try to figure out when to go out and see the northern lights. But we only get this information 2 to 3 days in advance, so it's not a lot of lead time. And the other thing about this is space weather is an emerging science. This is really difficult for even the world's leading scientists to predict. They're still sending out satellites and spacecraft to do more studies on this all the time. So if it's difficult for them to predict, it's going to be even more difficult for us to predict. And those forecasts are not always going to be right. So don't look at a forecast and say, okay, at 8:03 p.m. on Tuesday, the northern lights are going to be at K5 and I'm going to be out there. No, it might not be 8:03 p.m. exactly, though. They also come in patterns, though. So if you do go out to see the northern lights or chase them, I've started to recommend devote at least 3 hours to the experience. I know that sounds like a really long time, but the northern lights, when we get those really strong displays, they tend to come in waves. So you might go out and maybe you see all these amazing photos online and you think, oh man, I gotta get there in time. I want to get to my spot. And you're racing and you get there and you step out of the car and it's gone. Missed it. Darn it. Now, what you may not realize is even if you just missed that last show, if you wait about 20 to 30 minutes, maybe a little bit longer, that wave of aurora may come back a second time and it may be even stronger. And then sometimes during really strong displays, these waves can just keep coming overnight. Kind of like you think about the waves of the ocean, they come in and then they sort of, fade away, and then they come in and they fade away. The aurora does that, but I find that there's about 30-minute lulls in between some of these waves, and then some of the waves can last 30 minutes to an hour. And this pattern can go all night. So give yourself some time. And also, give yourself some safety while you're out there, some sleep if you can, and save your sanity because this is actually really tricky to chase the northern lights. I like to recommend that people know what their plans are for sleeping, especially if you're driving long distances, whether you can camp out in your car or you have a friend nearby or you've made a hotel reservation or at least make sure that there's some available, have a plan. But I mentioned safety, sleep, and sanity too, because this can just be really difficult. I mean, imagine if you put all of your stock into seeing the Northern Lights on Friday night and you're just counting on that to be the best thing that happens all month, and then it doesn't work out because this is so hard to predict. My number one tip is plan something exciting to do on the trip as you go out to chase the Northern Lights. Doesn't matter what it is. It could be hiking to a beautiful waterfall or taking a time lapse at sunset when you get there. Something that really excites you. Maybe you haven't allowed yourself to eat a donut for 6 months. Have a donut. I don't care what you do. Plan something exciting for your trip so that if you go out and chase the Northern Lights and you see nothing, you don't have to go home empty-handed. I think that'll make the chase a little bit more enjoyable. Okay, so we've talked a little bit about how to go out and chase the Northern Lights, but not what numbers to look for. This is a scale that talks about the K-index and geomagnetic storms, which really just means strong aurora storms. So the K-index is a measure of aurora strength that's measured on a scale of 0 to 9. 9 is the highest, 0 means nothing is happening, not even in Alaska. Now, once we get to KP4 or K4, I'm going to talk about KP too, because when you see that KP number, or if you're using an app, KP is actually a 3-hour average of aurora strength. And that 3-hour average may be from the 3 hours behind you. So once you get a KP alert and it's saying KP7, yes, the aurora might be at K7, but also the K7 may have happened 3 hours in the past and you just missed it. So just know that sometimes those KP alerts can be misleading. Now, so yeah, it's still the K-index though, so it's either K or KP. So on the K-index, once we get to 4, that's sort of as high as we can go where it's below storm levels. And this scale from the Space Weather Prediction Center sort of talks about some of the things that happen at the different storm levels. Once we hit K5, that's the same as the G1 storm. G1 storms are really exciting. They reach all the way down to the 45th parallel, and sometimes you can see it below the 45th parallel, and they bring some of these really strong northern lights. And if the other conditions are right, they also can bring some of those colors and movement and some of the spectacular things that we've seen. Maybe even Steve appears after the show. We'll talk about that. K6 is a G2 storm. That is actually going to be able to bring northern lights to the entire state of Michigan. Will you see it in Detroit? There's a lot of artificial light pollution there, so maybe not. But anywhere in the state of Michigan has the potential to see the aurora at a KP6, also a K6, or a G2 storm. So when we see those alerts, we get really excited. G3 storm is K7, a G4 storm is K8, and then we max out the scale at K9 with G5 storms. Now, if you were to read this up close, they have the KP listed here, but you can also sort of read some of the impacts of what's happening during these storms. So during a G5 storm, power systems may experience widespread voltage control problems and protective system problems can occur. Some grid systems may experience complete collapse or blackouts. So all of a sudden, we're seeing some of the impacts of the geomagnetic activity on the Earth and on our infrastructure. So this scale is really interesting to read. But for the sake of aurora chasing, what you need to know is anything above anything at a G1 storm for northern Michigan and then above for the rest of Michigan is good news because that's going to bring us brilliant shows of northern lights. Now, there are some groups out there that really discourage you from using the K-index or the KP forecast in general. Why is that? Because this is a tool that's mostly good for forecasting. Aurora is believed to be regional, and so it's different sort of in every region all over the globe. That doesn't mean it's happening necessarily at different strengths, but we see these waves and dips and curls. And so if you were to look at what was happening in the aurora over in Minnesota compared to what's happening in lower Michigan, you would probably see a lot of differences, even from aurora at the same time. So the K-index then is better as a forecasting tool, and it really doesn't work as well in real time. In real time, the people that I know who are really good aurora chasers and who are doing this forecasting are switching to other tools. So I recommend switching to the ovation model. And this is a really tricky website to get to, especially if you're looking for the still model. But if you go to my website at kaelinart.com/aurora, I've listed the link for the ovation model there, and you can find it there. The ovation model basically visualizes everything that's happening with the northern lights on a map so that you can see, as night rotates around the globe, what is going to happen when the aurora comes over the United States or Canada. And anytime this map turns yellow or red or orange, that's showing a high probability of northern lights, and it's actually telling you, okay, conditions are awesome right now, go outside. This model is also really cool because if you go to the website that I recommended, you can see this model in real time, and you can actually refresh that link just constantly. You know, if you're searching for the aurora and you just want to watch it all night and you want to wait until it pops, just hit refresh, 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 refresh. Just keep refreshing. And what's going to happen is you're going to see this change, because on this particular website, it's an actual forecasting model that's being graphed in real time, and the data is being collected by a satellite at the L1 point, which is just outside of Earth's atmosphere in outer space. And then that information is being fed into this model, and it's creating this graph. It even tells you the lead time. So this says this forecast has a lead time of 42 minutes. So just outside of Earth's atmosphere, this satellite is collecting this data, and in about 42 minutes, what's happening here is going to happen on Earth. The only way that would really change is if the BZ just sort of all of a sudden had a massive switch, or maybe if some of the data readings malfunctioned. But the forecast gives you the lead time. It actually gives you a number up here, the hemispheric power index, which is going to tell you how many gigawatts of hemispheric power we're seeing in the aurora. And anytime that goes above 90 or 100, it gets really exciting. So this map from Labor Day of last year is showing 104.3 gigawatts of hemispheric power. That red is all over the map. The probability is really high. And then all these other numbers are just times and dates and universal time. And it's telling you, hey, this is a really good time to get outside and see the northern lights. So, of course, we all love aurora. I thought I'd pop in some aurora photos. These were taken in Alaska. I had the opportunity to go up there and celebrate 10 years of aurora chasing in the fall. And believe it or not, these photos were taken on my iPhone 14 standard with a tripod. So if anyone is wondering what their iPhone can do with photos of the northern lights, it works pretty well. So chasing in Michigan. Here's a few photos from Michigan. I've actually been really excited to see some of these strong G storms that have been happening lately, and I've caught the aurora in Michigan every month so far this year. So I have some photos here. This one is actually from 2021 up in the Upper Peninsula. I went on an aurora chase with some friends, and my friend Bonnie T got an amazing photo of me there under the northern lights. But this photo is from March 23rd. It was taken just north of Flint, Michigan. And that aurora was happening during a very strong storm. I believe it was G3 storm at the time. And I could actually see a lot of this color with my own eye. And then this photo was taken just east of Lansing, Michigan, on February 26th, if anyone remembers the February 26th aurora display. And I could also see these pink pillars and some of this green with my own eye. So we have seen some really, really strong aurora activity lately, and it's just going to keep getting better as we head to the solar maximum of solar activity, which is coming in 2025. So we've got a few more good years of this. Here's the KP index sort of mapped out. If you can't see it, this is KP3 all the way up in Canada. KP5 reaches down into the top of Michigan, and these values are really showing you where the aurora would be overhead. So this would also be visible, this KP5, from the middle of Michigan, but that would then be low on the northern horizon. It jumps numbers here, so KP7 is the yellow line, and KP6 is right in the middle there. Once we get to KP7, aurora is coming overhead all the way down into these other states, and once we reach KP9, it can keep pushing down into the southern US and beyond. I recently took it on myself to try to map this out for Michigan, though, and show in a little bit more detail what's happening here. And I know the numbers are really small, but essentially, these are the latitudes in Michigan, or I'm sorry, these are the parallels of Michigan, showing the different latitude. So at the 47th parallel, we're all the way up entering the Keweenaw Peninsula up at the top. They only need a K4 to see the aurora there, or a KP4. We also only really need a K4 to see the aurora in the bottom of the UP. And you can probably see this low on the horizon from just south of the bridge. Now, once you get into northern Michigan, you really need that K5, K5. This is the 45th parallel right here. We're below the 45th parallel and below the 44th, and I think just below the 43rd, so we're like in this area. But you'll need a K5 at the 45th and 44th, and then a K6 at the 43rd and the 42nd, most likely. Now again, this varies a lot because you may be able to see some of these values low on the northern horizon from a little bit further south. This is a light pollution map. This is really going to tell you where your dark skies are in Michigan, and the link is lightpollutionmap.info. It's just a website you can go to. You can kind of look at Michigan and you can see, okay, in these red and purple centers, these are the really bad areas of light pollution. Anyone know what this is? Chicago. Chicago, yeah. Chicago has a really hard time seeing the dark sky or any northern lights. Detroit is almost as bad just because of the massive amounts of light pollution. And we're just north of there. So I actually went to this map and I zoomed in on the Oxford Parks area. And Oxford, I believe, is right here. So we're north of Detroit, but we also have a city over here that's sort of to our northwest, and another city north of that. If you were to, walk outside here and look north, you would actually be able to see the light pollution from that pretty well, sort of off in the distance. Now, it's not directly to your north, so you're actually not too bad. A little spot like this is going to be easier to overcome when it comes to looking at your dark skies. But if you really zoom in and spend some time on this map, you can see, okay, as we move over here to the east, there are some darker areas. Once you get to the lakeshore, it gets a lot darker. Once you head up to Port Austin, then you're really getting into some good visibility. And as long as you don't have one of these major light pollution centers right above you to your north, then you should be in pretty good shape. I've also noticed, because I have always lived in cities for the most part, at least since I was a kid, I have also noticed that during a really strong aurora display, it is possible to see the aurora from some of these orange and yellow areas, even in the orange, if you find a really good patch, or a really good park or a really good view. But it does have to be a really strong aurora in order to be able to see it in those light polluted areas. All right, this is the Space Weather Prediction Center forecast, which I can tell you how to read if you want. Does anyone have any questions so far? Just a lot of information. So the aurora forecast, the standard that we use, comes from NOAA's Space Weather Prediction Center. And they issue the 3-day forecast for aurora, which is going to be the most reliable information we have, from the folks who are actually professionally trained to forecast this stuff. What you're going to see when you look at these forecasts is, it gives you the information when the forecast was issued. The greatest observed KP over the past 24 hours was 5. In this instance, the greatest inspected KP is 6.6, so this was actually a really good forecast, but it's an old one from May 11th of 2023. And what you're going to see here is the numbers for May 11th, May 12th, and May 13th. They're going to give that in a 3-hour period of time. So this is 3-hour increments of universal time, and that's what that UT means. And each of those 3-hour periods then has a K from the K index. And once you reach into those storm levels, then you then see G1 and G2 forecasted. At the bottom, they'll give you a rationale. You know, they believe that this forecast will pan out because of the arrival of an anticipated CME later in the day, which will likely lead to G1 to G3 storm levels. I think that was a forecast that we were really excited for. So, and I can answer questions for anyone if you have them later on about that. Here are just some photos from the Michigan Aurora Chasers group. We've had some really awesome chases over the past year, and everyone has posted phenomenal photos. Even as I keep bumping into the screen here. But this is STEVE. It's an acronym that is actually a subthermal emission enhancement. It's not an aurora, but it's related to the aurora, and you can actually see it in a different portion of the sky. So we were able to catch STEVE and what they call the picket fence, which is this really stripy fence that often appears beside STEVE. And obviously some awesome photos from storm levels too. And here's another chase where we posted some photos. There are always really amazing photography in the group, and we have lots of tips in the Michigan Aurora Chasers on how to take photos too. So we're hoping to do another live chase where we have everyone gather and join us, and we actually see the Northern Lights together. So far, the forecasts have not really been working out since we entered May, and we really try to do these during the warmer months when there's no snow on the ground, but hopefully there will be another live chase soon. And then, of course, here's my book, Below the 45th Parallel. I have copies if anyone wants to pick one up tonight. For sale, and I'm happy to answer any questions you guys have. We also have a lot of cool events coming up, so check those out. And yeah, I think that's most of what I have for you. I'm happy to answer questions on anything. And good luck on the Aurora Chasing Trail.
For universal time, how do you convert it to our time zone?
Yeah, so you have to keep in mind daylight savings time and how that changes. But currently, universal time, you would subtract 3 hours from that to get local Michigan time. Now, some people look at universal time and you'll also notice it looks like military time. So first you have to subtract, the 4 hours, and then you have to convert it. So if you have 1500, that ends, in the end, that ends up being, 3 p.m. Yeah.
So it's not Greenwich time, it's a different.
Yeah, yep. So subtract 4 hours during this time of year to do the time conversion. And I actually have a quick guide that I post in the group too that makes it really easy on people. If you search Noah's Ready Tools, they have a time conversion guide that's really easy. Any other questions? Yeah.
Is there a particular time of year that's better, spring, summer, fall? What do we, we're not going to look at the websites all the time. Right. So when should we be more active looking?
Yeah, the question is, what's a good time of year? Is any season better? And actually, peak aurora season falls between September to April of every year. And that's largely because we have longer nights. We get many more hours of darkness, but there's also something about the winter that makes the BZ more cooperative and actually lets that energy funnel into Earth's atmosphere without any trouble. So winter, I guess after September, so the late fall to winter to early spring would be believed to be the best time. But they can happen any time of year.
Yeah, I've got the space weather app. It says KP3. Is that location driven of where I am right now, or is it a certain area?
So if you have KP3 on the Space Weather app, is that driven by the location of where you are right now? No, it's going to be KP3 everywhere because that's an average that, the reason it's KP actually is because it's the K index taken in a planetary average, P for planetary, all over the globe. And so they've averaged numbers from across the world to get KP3, and that's going to be the same no matter where you are. Now, if you're farther north, KP is going to be really important to you because that means you might see something, you know, all the way up in Canada. But, you know, if you have KP3 and you're down here, then it doesn't mean a whole lot, unfortunately. Yeah, another question in the back.
You were saying earlier that the solar winds have got to be, shall we say, a negative charge, right? Now the Earth's the magnet, north and south. So if it's a positive charge and we repel it, does that mean in Australia that's good omen for them that they're going to attract it and have a...
No, because that charge actually, it's actually the magnet and the repelling effect is actually sort of happening between the magnetic field carried in the solar wind, which is flying through space, and in Earth's magnetic field. And the magnetic field is going to have the same properties sort of all the way around, I believe. And so I know for a fact that it's not going to be any better in Australia if it's a negative charge than it is here. But if we see that negative charge, that's good news for us. And if we see the positive BZ, that's when we're worried that we're not going to get any activity. Did I see another question here?
So below the 45th parallel, we're looking for a KP of 4, 3.
So if you're in the Upper Peninsula, 4 is all you need. At the 45th parallel, I believe you can see aurora pretty well, pretty reliably with a K5. Below the 45th parallel, we actually need a K6 or a KP6. So 6 is the magic number that brings aurora to the entire state, and that's the same as a G2 storm on the scale.
Okay, then we're looking for a negative BZ.
Yep.
And we're looking
Negative
for
BZ.
a clear night.
Yes, and a clear night, which sometimes I love Michigan, but 4 of the 5 Great Lakes prefer Michigan, and with our beautiful lakes and lake effect weather, we also get so many beautiful clouds. It makes it a little bit difficult. Other questions? Yeah.
Yeah, making some photographic comments. Two-part question. You mentioned a 30-second exposure. What happened in that sky? Is that blurring?
Yeah, so a 2-part question. If you use a 30-second exposure in photography, what happens in the sky and does it blur? Yes, so actually when you see the aurora, especially if you see a really strong aurora, there's going to be a lot of movement. You'll see these pillars shoot up into the sky. You'll see it swirl. You can see it sort of pulse and dance and sort of dart around the sky. A couple of the storms really recently had a lot of movement and a lot of activity. So in that 30-second exposure, it's going to blur all of that. And you could actually go down to a 10-second exposure to capture 10 seconds of light and color, but less blurring of that motion. Some people like to use an even shorter exposure time to get really distinctive, pillars and some of that structure coming through in the photograph.
So as you change that timing, you're changing either your f-stop to a wider opening, correct? Or you're increasing what's called your ASA setting, or the sensitivity of the film base or whatever you're using.
Yeah, I'm not an expert on f-stops, but if you're increasing that exposure time, you're letting more light into the camera and more color, and it's also going to blur it. Yep, and it's going to open that up more. Yeah. Other questions? Does anyone feel like they feel a little bit more prepared to see the aurora? Know what to look for?
I've been trying to explore a lot of the different spots to find the different things, but what is the cloud spot, so to go to, or site, or best?
The cloud spot?
Just to know what the cloud cover is going to be.
Oh, okay, yeah. So if you're going to all these different sites and sources, where do you go to find cloud cover and something reliable? Well, I actually learned last year that cloud cover is also extremely hard to predict. It's one of the hardest things that weather professionals and meteorologists have predicting. So it can change really quickly. So even if you find a really good cloud forecast, take it with a grain of salt, because anything can happen, and that could cloud completely over, or the clouds could blow out. There are some places you can go though. I recently started using more the app called Astrospheric, and that's actually going to tell you about cloud cover, and it's going to tell you about clear skies, and it's going to tell you what night of the week is looking the best for stargazing, astrophotography, and just clear skies in general. So if you want something really fancy, Astrospheric, a lot of people really like the app called Windy. It's got sort of a red and white icon, and that shows you cloud cover too. But again, these things change so frequently. I mean, you could also go to your local weather station or local weather channel or weather.com or weather.gov and see what you can find. But, some people kind of like to triangulate the data and look at 3 different cloud maps and then figure out, okay, what's most promising between all these 3? Where do they agree? So yeah, any source you can use is going to help.
Melissa, what about, when you're out in the dark, we obviously know our eyes need to adjust to see things. But then when we're trying to look up information and it's awfully bright, you got this is there some tips that you've discovered that are helpful for kind of like trying to be in the dark and look up stuff that's bright?
Yeah, so the question is, what happens if you're looking at all this data on your phone and it's really bright light and you haven't let your eyes adjust to dark? That's something I didn't mention. It's really important when you're trying to see the aurora to walk out into the dark, stand there looking at the dark and the north, and just let your eyes soak in the night and the darkness. It starts to feel a little creepy and a little scary, and it starts to feel really, really dark. Actually, you start to see a little bit more though. And once your eyes are fully adjusted and your night vision is activated, then you can start to see the movement of the aurora better and the color. And I recommend trying to let your eyes adjust to dark for at least 5 minutes, but you're right. Every time you look at your cell phone or your computer or an app, you're going to ruin that night vision. You're going back to ground zero when it comes to being able to see well in the dark. So there are a couple of things you can do. Many phones now in the accessibility settings have a filter that you can turn on that sort of dims down the color of your phone at night. And you can put this on a short command so that you can turn it on with a triple click or whatever. That's what I did on my phone. They have like a red filter that you can put over it. Other phones have a night mode. You can put it on night mode, or you can even turn your apps, if you're using the white background, to a black background, which will help keep your phone darker so that every time you sneak a peek at it, you're hopefully not losing all your night vision. And then, a lot of people will walk out there with flashlights or telescopes or anything that they think will help them see in the dark. You really want to minimize any of that light that you're using once you get out there, and try to be cognizant of other photographers so that you don't shine the light on them too. But just keep the lights off as much as possible. I'm really bad at this because I'm trying to update the group on whether the data is looking good or not, even while I'm aurora chasing. But every time you look at your app, you're losing your night vision again. So.
Wasn't there an app that you put on your phone that makes everything red?
Yeah, there might be an app for that. Does anyone know of an app that has a red filter?
We're up north,
I can't remember what it's called. I think there is one.
and the crowd told us at the dark park, and we hurried up and put it on there. And then your phone was always had this hue of red, and you couldn't walk in there in the dark park without that.
Yeah, dark parks actually have rules against having those lights on while you're out there, so that you can maintain those dark skies. So I think there is an app to get the red filter on your phone, but I'm not sure what it's called off the top of my head. Oh no. Do you guys have any other questions? I see one in the back.
I had seen somewhere on the site, I think, that even if you don't see it with, and you may have covered this earlier and I missed it, but if you can't see it with your eye, that put up your camera to look.
Yeah, absolutely. So because cameras capture all the light and color in the night sky, and our eye doesn't necessarily, if you're not seeing the aurora but you think you should be, take a test shot. Even if you just have a cell phone, or if you have a DSLR camera, maybe it's not on the tripod yet, hold that up, point it north, try to get it really steady, And then if you have it on the right settings, take a photo. What you see on that photo might reveal to you something that you didn't know was there. So the camera is actually going to be capable of seeing the northern lights before you are. And if you catch something really incredible or some really incredible colors on your phone, that might be a sign that it's about to pick up strength and present itself to your eyes. And one of the reasons it's so hard to talk about what you'll see with your own eyes in the dark too is because everyone has their own unique night vision, and humans are not nocturnal. We're not designed to see in the dark. So we have limitations in the rods and cones of our eyes that make it hard to see color in the dark. And actually every single person, it could be whether you wear contact lenses, or I do, or glasses, corrective lenses, or if you have cataracts, or even, age can be a factor. So everyone's night sky vision or night vision is different. And so someone out there beside you, may see more or less color than what you're seeing, because everyone's experience is going to be different in the dark.
Night vision goggles like they wear in the army, that wouldn't do any good.
Would night vision goggles help? Would they do any good? I actually have a friend who tried that. He said it didn't work all that well, but he recommended trying infrared goggles. So it's possible that goggles might change your experience, but unfortunately, I don't think they've designed a pair of goggles yet that's going to be able to replicate that camera experience of the colors on your camera. Now, if you go to the polar regions of the world, go all the way up to Alaska or Norway or Iceland or Sweden, you're actually going to be able to see a lot of that color, because those photographs really do represent, for most people, again, our night vision is different for each individual, but those really do represent what you see when you're that far north. Unfortunately, because the northern lights are filtering down to us through the North Pole, they have to have so much strength and power and density to reach us here that they can be really dimmed down by the time they reach the middle of Michigan or southern Michigan.
Does that time frame of fall to early spring apply to all those countries? Like if you were going to take a trip?
Well, if you're planning a trip to see the northern lights in another country, you can keep in mind that the winter months, are the peak time for seeing the northern lights, that between the fall equinox and the spring equinox. But you also have to keep in mind some countries experience the midnight sun, and they may not have any darkness at all if you go too early in the fall or too late in the spring. So those times can be helpful, but also, another thing that I've learned is I've met so many people who have gone, especially to Iceland, it seems like, or to the coast of Alaska to see the northern lights, and they have spent an entire week there and saw nothing. And that was entirely dependent on cloud cover and whether or not they got clear skies. So another thing, if you're planning a trip to see the northern lights, that you may want to look at is average monthly cloud cover for that region or that country, so that you're going at a time of year that's going to have some really beautiful starry skies, because that's when we can see the northern lights.
This is like morale.
Yeah. Yeah, it's really tricky. But once you see it, it's so worth it. I think for a lot of people, it's just life-changing. If nothing else, if you catch it during a really strong storm, the movement and the colors can just be absolutely stunning, and unlike anything else that I've seen on Earth anyway. Yeah, one more question?
No, it's something that I do. She's never seen the northern lights, so I try every week to get the forecast, and at the NOAA space page,
Yeah.
you can subscribe, and every Monday you get a
Yeah.
forecast, plus during the week they'll update it.
Yeah, absolutely. If you go to the Space Weather Prediction Center, you can subscribe for emails with the forecast, and you can actually get them delivered to your email. And that's how I get my alerts about when the northern lights may be active. You can subscribe to the 3-day forecast, or you can get all the alerts and warnings and watches anytime that they're thinking we might see a G1 storm or a G2 storm or a G3 storm. And those are what I really watch.
And then you don't get any sleep.
Yep, that's absolutely right. Who needs sleep, right?
No.
All right, well, thank you so much, everyone. I will be hanging out, and I would be happy to sign any books for you in the back and answer more questions. And I just really appreciate all of you being here today, and good luck.